This evidence-based practice guide comes from the Improving Mathematical Problem Solving in Grades 4 through 8 practice guide. The guide is composed of recommendations that are evidence-based strategies for teachers to use to help enhance and improve problem-solving skills for students in grades 4 through 8. The first recommendation says to prepare problems and use them in whole class instruction. The purpose of this recommendation is to make sure that students have the necessary language and math content knowledge to solve problems. It is reported that the evidence is minimal because no studies meeting the What Works clearing standards directly examine the issue, but it is believed that the recommendation will still benefit learners. Ways to perform the recommendations are to 1. Include both routine and non-routine problems in problem-solving activities. The routine problems to use will include problems that can be solved using familiar methods in a step-by-step process. The non-routine problems are not predictable, and students have to take more time to interpret the problem. The second way to perform the recommendation is to ensure that the students will understand the problem by addressing issues students might encounter with the problem's context or language. This can be achieved by choosing problems that students are more familiar with. Also, the teacher must clarify and identify unfamiliar language and context. Students may also benefit from the rewording of problems when they can make connections from their own experiences. The third way to carry out the recommendation is to consider the student's knowledge of mathematical content when planning the lesson. This helps the lesson run smoothly, and you can consider the student's knowledge and you are prepared to overcome any roadblocks. Recommendation 2 states to assist students in monitoring and reflecting on the problem-solving process. When students monitor and reflect while problem-solving, they are able to think about what they are doing and why. The evidence that supports this recommendation is strong because it was tested and the recommendation consistently found positive results. The steps used to carry out the recommendation include providing students with a list of prompts to help them monitor and reflect during the problem-solving process. The prompts should be questions that require the students to think through the problem. Questions can include, what is the problem asking? Which information in the problem is relevant? Teachers are also encouraged to model how to monitor and reflect on the problem-solving process. Also, the teachers are urged to use student thinking about a problem to develop the student's ability to monitor and reflect. Basically, it's saying to ask students questions to get them to reason through the methods or steps they tried and why they did or didn't work. The third recommendation is that teachers should teach students how to use visual representations. Visual representations help students link mathematical operations to solve problems. Because the student samples found that visual representation improved achievement, the evidence for this recommendation is said to be strong. One way to carry out this recommendation is to select visual representations that are appropriate for the student and the problems they are solving. Think alouds and discussions are also suggested to teach students how to represent problems visually. Then after the students represent the problem visually, they should be taught to convert the visual representation information into mathematical notation. Recommendation 4 says that students should be exposed to multiple problem-solving strategies. This helps the students to be able to choose the strategy or method that is easiest for them. This helps by providing instruction in multiple strategies like guess and check, thinking logically, using objects, making tables or number sentences to help solve problems. Students should also be provided opportunities to compare multiple strategies and worked examples. Teachers should ask questions such as, how are these strategies similar? How are these strategies different? Then ask students to generate and share multiple strategies for solving a problem. The last recommendation is to help students recognize and articulate mathematical concepts and notation. This is done by describing relevant mathematical concept and notation and relate them to problem-solving activities. Take opportunities to link students' informal language of math concepts to formal mathematical notations. Students should be asked to explain each step used to solve a problem in a worked example. Small groups can be used to encourage students to discuss the steps they use to solve problems. Lastly, help the students make sense of algebraic notations. Teachers should introduce symbolic notation early to students so that can increase their understanding of the problem-solving process. This is an example to show how the recommendations in this evidence practice guide can be used. There's a problem. There's also a space for a visual representation. It gives the students a chance to explain how they solve the problem, and a workspace to show the mathematical notations that were used. The recommendations in this guide is to help teachers improve problem-solving strategies.